and horizontal capability or platform. It shouldn't be isolated to different verticals of application. So you don't need a set of things for manufacturing, for connected vehicles, for smart grid. You need only one. And this one thing does a few very fundamental capabilities that as fundamental actually, just as sending a package from A to B or locating a file that's everywhere. So this is actually, you're distributing the computing capabilities from your cloud all the way out closer to the end users, and then you go use them. A third characteristic that seems to be shared by most people is that this ought to be in a standard space. It shouldn't be a closed proprietary thing. So this gives actually people a very, very important opportunity. So think back 15 years ago when people was designing cloud computing. People largely missed the beginning of the process. So part of that caused sort of a cloud computing even today still remain to a large extent proprietary in many scenarios, right? And that trend still continues. When people started to build cloud, fog, and edge computing, this is actually a very, very good opportunity for us to actually do it in a standard space way. So this is more important because fog and edge computing are going to be much more distributed, are going to involve more players, are going to have to work in more sort of environments. So a standards-based solution will be much more critical. So that's why I'm very, if you look at the industry, and almost every single major player in the cloud space are developing something similar. They're all releasing products. They may not call it fog computing or even edge computing, but they're doing similar things. So I want to sort of summarize those observations to share with everybody, and that's sort of the several things I want to have in mind. Thank you all very much.
Next speaker is Tom. I will do them in sequence. I don't have to keep going up and down, okay? Hi, I'm Tom.
Okay, so I'm the second speaker here. I'm going to talk a little bit about well, I'm going to talk about into fog or the edge, whatever you want to call it, in terms of consumer electronics. As soon as my talk comes up here, I do that. That's what you looks like a slider's presentation.
It was working before.
It was working before. I'm not sure. I can't even find a PowerPoint.
You had some nice slides. It would be.
I did.
Yeah.
You know, sometimes slides don't happen.
Is it better read that?
Oh, I took it off the. I took this out just so I can see if I can get it to work without that. can you find me out? Oh, wait, there's the watch. No, that's for files, I'm looking for.
Are you using the launcher?
Yeah, that's what I'm looking at right now. There's one. Okay, let's see what's up. All right, something weird is happening. Okay, we're gonna go without the slide. So, what's it? I didn't put up.
Would you mind to check whether the projectors are?
Oh, I don't think so. There's something weird going on up here.
Ah.
It's acting like it's never had PowerPoint running before.
But how we need to use the microphone?
I should use the microphone. Okay. So, the point I was gonna make is that, there's an awful lot of things that we're gonna have on our consumer devices that are gonna be connected, that are gonna be generating data. And, and there's gonna be, facilities to be able to work on, between all the high resolution content, between the IoT, all of the sensor, technologies that are generating content. We're gonna need things that are, and a lot of this stuff needs to be processed real time. It's like automobile information, in order to involve cars, ADS or other type systems. We're going to have to be able to work on that data right now. And so the latencies of having data have to go up to the cloud in some data center somewhere to process it are just going to be too big. So there's definitely going to be a need, and consumer electronics is going to be driving for a lot of different reasons, for all the different things we're trying to do. The need for processing both locally in devices and also at the edge. And there's developing with the movement also to 5G technologies or higher wireless communication that we've talked about here. People are talking about, actually part of that whole 5G implementation is, for instance, to be able to support IoT type applications. And there also are people that are looking at, as part of that, just because it's so much data, and also tying into like smart cities, infrastructure, things of that sort. We will actually be putting essentially small data centers into our cellular systems. So that's going to be driving new ways in which, it's talking about storage, memory, it's going to be new ways in which we store and access information. That's going to be happening at the local level, it's going to be happening at the edge, it's going to be happening in the cloud with big data centers. And it's going to be also driving the need for, first of all, an enormous amount of data generated. Not all the data needs to be kept. Needs to be instantly available. So there's going to be differences in latency depending upon the criticality of information. So some stuff's kept for long term, some stuff's needed right now. And so there's going to be a need for different types of storage in different places to be able to support this. And this is going to be, so, and we're going to end up with a big infrastructure of different types of storage, different places. And that's going to be an important part of what we're going to be, what's going to be capable. At the same time, as you heard before in our future directions, Lee Stogner was saying that battery technology, for instance, is developing. So right now we're using things like this. Eventually we'll be able to build a lot of more integration, maybe with special purpose processors, maybe with new types of non-volatile memory technologies versus the volatile ones we use. Yeah, we'll be able to both increase the power available in mobile devices that we use every day, but also decrease the need for power. And eventually this could be our interface device, with voice and with gestures to use our glasses and actually run the electronics in there. I think having something leaves your hands free that we could do things and still interact with our data is going to be the way of the future. So all of these technologies leading to this, the things that we conceive in science fiction are being enabled by the technologies that we're working on. Indeed, as we said before, by 2020, in order to make that happen, we're going to have more processing, more data capable, both locally in the devices that we'll have in ourselves and around ourselves, and the edge of everything, and also probably in big data centers. So I think, although my slides have a bit more than that in there, I think that's a good start, because we do want to get into a panel discussion. Thank you.
If it doesn't work, then I will have a slide talk as well here.
Slides were
It's lucky here.
It may be a slide as session. This one, let me see. So, shall I try to cut again?
It's HDMI 1 is the cable.
So should I use the HDMI one or the?
Either one, or you can use that one.
Just plug in number 1.
If you've got HDMI, HDMI 1 works.
Oh, okay.
Oh,
Get this to work.
hey guys.
Nice slides.
It's there. Like how that's-
Ah,
All right.
He's got slides.
finally. So, I think I have to take up those, a little bit of Alex's role here, so talk about a little bit about standard and a little bit about the technology. Okay, so I'm John. I'm still a faculty member at the Taiwan University, Taiwan University. There's a lot of Japan University in China, totally, I think 7 of them, right? So we're one of them. And I'm also deeply involved in open fog through Tao's introduction and support. I'm involved also in ICCE standard committee as well. So let me talk a little bit about both about the architecture that we're developing and also how do we push it, that's like Tao has said, into standards. To answer your last question, probably poorly, what will happen in 200 years, I think I would say what will happen in 20 years. I think from time to time, all the folks in open fog when we were designing the architecture. Oh, okay, sure. We from time to time, we jokingly say that we are building the standard. And I think in a sense we're building a standard. I hope that we don't need pre-terminators to attack us. Consider that way. This as Tao has said, this architecture, computing, communication, and storage architecture that permeating all the way from the IoT things all the way to the cloud infrastructure. This permeating thing is providing computing along with connectivity, and then we are deploying AI and we're deploying blockchain digital ledger onto it, and hand over a lot of our decision making to this infrastructure, because simply we are not fast enough. Human beings are not fast enough in doing the job. For example, in the 5G, if we want to support both high throughput connections as well as low latency connections, as high failure connections, and want to allocate our bandwidth dynamically, I don't think any mechanical manual algorithm can help us to do that. So we are seeing my feeling when we are all designing this thing with our colleagues is that we are really, if we put it in the context of the 5G, the IoT, and then this fog and cloud computing, we're deploying one of the biggest infrastructure ever. Not only the biggest information infrastructure, probably one of the biggest infrastructure ever. So this is exciting, and that's the reason why I get involved in this. So let me just use a few slides to talk about what we are doing, and instead of doing all those animation, I'll just kind of walk through that, and then a lot of time for us to have dialogues. Okay. Put it simply, what is edge and fog computing? It's basically distributed cloud computing. What it means is that we want to put whatever people initially want to put in the cloud, in the data centers, we want to now disperse it and allow it to run in a distributed platform. The distributed platform including things, one of these days will be in your set-top box. Your set-top box now only mainly doing routing packets. But consider if you put several terabytes of memory, putting GPU, NPU, TPU, TensorFlow processor, whatever, into it, it will become a very powerful processor and process whatever your personal data and analytics would demand. It can be a roadside, curb chassis that used to only control traffic lights, but now it's doing all the connected vehicle intelligent transportation system that Tao has been very familiar with. It can be, things in your factory that connects all your factory. Now we can do predictive analytics or doing process monitoring all the way through the supply chain. So what we are trying to do is we're trying to make whatever you want to do in cloud computing in all those platforms. But how do we do that? Basically, the way to do it, according to what my colleagues and including Tao has been doing, to build a common, as Tao has alleged, not a proprietary, but a more common and open architecture. What we are building is what we call a bowl. A bowl to contain a soup. Now, what is the soup? The soup is the environment that you use to run in the cloud, the application execution environment, the VM that you created, and then you put your own middleware, your own software stack, and then your own application service on it, depends on whether you're providing PaaS, SaaS, or whatever. So you want to have that unchanged. Whatever you can do in the cloud, you want it to be unchanged, and you can move it over to run it in your fog node or edge node, whatever that fog node or edge node is located. So what does it take? We need a virtualization environment in all those distributed devices. And the virtualization environment, if we do it in the most simple way, it consists of these three slabs, you can say. One of them is lying right really, at the very foundation of it, is our trusted computing base, the trusted computing platform. We mandated it now, and I think there's a common consensus now in the community. We have to have hardware root of trust, and we have to have trusted hardware as well as secure booting to allow us to create a trusted execution environment that can support the most essential security and trusted computing services that all the other things would use. So the first slab is that part. The second slab is end-to-end security. We want the end-to-end means whatever service or microservice module that you're running in your thing, when they want to communicate, exchange information across this whole continuum to another microservice running in accordance with you to provide a overall application, they can be trusted, they can be secure. And finally, of course, we have to extend whatever that's now currently in the cloud to do the cloud platform management and the cloud service management to become a distributed management structure that manages all these nodes, so that the distributed node management as well as the distributed service and application management. Of course, in that respect, we are hoping that, at least in the open source space, Kubernetes can be extended in an appropriate manner to at least do some of the tasks that they can do. So this is the concept that this is the bowl that we're building to support whatever originally people are supporting in the data center. And in open source architecture, the beautiful thing, I really like the architecture, which was actually initiated by Tao and Mengcheng and a few other pioneers. The beauty of it is that it's centered around only one logical or virtual or physical entity, the concept of fog node, or you can call edge node now. That edge node or fog node is exactly implementing this bowl to support this application execution environment. However, this node is designed to communicate horizontally what we call east and westbound, and vertically what we call south and northbound. The south and northbound allow us to go through the continuum, connecting everything from the IoT devices and the mobile devices, we don't forget them, to the fog node. And then throughout the layer of these fog node, ultimately to the cloud. We don't want to click the cloud. Our cloud is our ultimate reservoir of information, models, a lot of things. So We want to connect to them, but we want to distribute the computing capability and storage capability all over the continuum. And furthermore, we wanted to be able to connect, horizontally to other fault nodes. Currently, I know that most of the applications are just basically doing a star-shaped architecture. Whatever we have in the cloud, we want to stretch it, to one of more edge nodes in the edge. But ultimately, you will find that you need, think of it, if you are doing a smart building or a smart city, ultimately you will need multiple of these fault nodes connected together to form a network. And the network will be controlled by a high-level, high-tier network, ultimately to the cloud, to control the whole city. So we need that the east and west communication as well to connect all the tier fault nodes together. All these things requires us to do interoperability. This is power problem. This is
It's cursed. There it is.
and that's the replication. Anyways, all these things require us to do interconnectivity, of course, but so we mandated everything to be IP adapted. Of course, I know we know about the brownfield OT, they use different kind of protocol. We hope that there will be appropriate proxy there and gateway there to do the necessary IP translation. And then there will be interoperability, of course, there will be composability. The whole thing should look like not different pieces of fault node, just like what we have in a data center. The whole thing looks like the whole reservoir of computing and communication resources. And finally, of course, if you want to own the whole thing, this is not in a physically protected data center, but spread all over the place. To be trustworthy, you have to have trust and security. So I'm preaching to the cloud, and I'm using a lot of time. So let me just kind of move far forward to give you guys some of the things that we have already done. For example, this is what we draw about the trusted computing platform, and we also suggest that we follow, we don't invent our own standards in many cases. We suggest that people look into the Global Platform Standard for TEE, look at the TCG Trusted Platform Module spec for doing the hardware root of trust. And then we also, of course, look at how people do trusted communication these days, secure communication these days, using basically using HTTP and TLS or COAP and DTLS, and inside it we can run all sorts of web service messaging. And of course, we also, this is all now into the ICCE standard that we just finished adopting, and also married with the transaction protocol, the service protocol that's at the upper layer. This is definitely not an exhaustive list, but this is a list that goes to our members. And we already see, there, of course, as Tao has mentioned, there's a lot of proprietary implementation, but EdgeX Foundry, partly supported by VM and VMware and Dell, has already made an open source implementation, the EdgeX implementation, which actually, if you compare them with the architecture, because Jim and the team also work with us closely. They're a member of the architecture working group. They designed the whole architecture itself is very, very similar to the proposed framework architecture. And the amazing thing what they have done is that they show us that they can actually provide most of these things that's in the bowl, and even something around the bowl, especially the management part, all in microservices, and then being managed by Kubernetes. So we can see that a open source implementation of the whole architecture is possible, and we can grow it. So I'm inviting all of you to, especially in the consumer electronics community, to think about it, as Thomas suggested. In one of these days, I think it's not really, I think less than 10 years. This thing,
Yeah.
Everything. I'm actually working on PCI, brain computer interface as well.
That's part of it.
The first thing that get me involved in the fall is that we need those things to analyze the real-time brain state. We cannot wait until you get to the cloud and then you lose connectivity and availability, etc., etc., etc. But anyways, let me just then do something that I think Alex or Doug would like me to do, is to tell you a little bit about the standard activity that we've been doing through ICCE SA, the Standard Association. As Carl said, that standard is very important. You know, if we want to make this a really truly dispersed and distributed architecture, how can you not have standards? And then that was built into Carl's, I think when they first founded the Open Core Consortium, they already had this built in, is that the technology development would go hand in hand with standard development. Under their recommendation and their help and also the help from Doug and Russell and Alex and Rob, everyone, we formed the 1934 standard working group. And the formal name of the working group is for Computing and Networking Architecture Framework Working Group. And then we also formed a new standard committee to support these and related activities. And that one has an even longer name, should be Communication Society Edge for Cloud Communication